let's get started with lesson 13.2 in our Big Ideas book, page 574, where we're going to continue with graphing linear equations. And today we're going to apply what we learned to find the slopes of lines from graphs and tables. We're also going to learn about slopes of parallel and perpendicular lines. Ladies and gentlemen, our essential question: how do you use slope of a line to describe the line? So you had a lot of notes to take, and we got to rehash a lot of them because it's so much to know. So here we go. Slope is probably super critical to the understanding of everything we're going to be doing moving forward with graphing. We got to know slope. So constant rate of change between any 2 points is called, the slope. It's called the slope of a line. The slope is represented by the letter M. So when we look at equations and we see the letter M, or we see the letter M with something next to it, we understand that that means slope of something. M means slope, and slope is a ratio. Hey, we just did ratios, the comparison of two numbers by division. Slope is a ratio. Now remember, a ratio can be a fraction, and that fraction can look like an improper fraction. You can have a greater number in the top than you have in the bottom. We never simplify a ratio to a mixed number. So if we're talking slope, that ratio has to stay as an improper fraction if that's the way it looks. So it's a ratio, and that ratio is the change in y, that's the rise, to the change in x, that's the run, between any 2 points. Those points x1, y1, and x2, y2 on a line. So let's take all of that we just said and make it look like an equation. So slope M. Slope M. What is slope M? Well, it's the rise to the run. Let's talk about rise to run first. So take a look at our graph here. Rise to run. We always read a graph, just like you read words on a page in here in America, from the left to the right. So we start from some point on the left, and we move to a point on the right. And the first thing we're going to do is rise. And then we're going to run. So in looking at this graph, this chart that I gave you, starting at point A, which is on the left, and moving to point B, we're going to rise. And it says right there that we're going to rise 4. So it went up 1, 2, 3, 4 units. And when it got to the same level as B, we then turn and ran, and we run to the right, and it runs 2. So the rise to the run on this one would be 4 over 2. Now that can be simplified. What can it be simplified? 2 over 1. And I'm going to tell you something that's probably going to mess you up. I said you would never make a ratio a mixed number. But if I simplify this, it will not be a mixed number. This is a slope of 2. And if you have a slope of 2, in fact, if you have a slope of any number, you know it's a ratio. And if you don't see the run, in other words, if you don't see the bottom half of that ratio, you have to know that it's equal to 1. So a slope of 2 means we're rising 2 and running 1. And if we come to this graph, I can go up 1, 2 and over 1, and I'd be right on the graph again. And then go up 1, 2 and over 1, and I'm on B. So that's how that works. If you don't see the run, it's equal to 1. Ladies and gentlemen. So now another interesting thing about rise. Sometimes we might have to go down to get to point B, from the left to the right, from A. So rise can go up or down. You have a positive slope if it goes up. You have a negative slope if it goes down. So there is a possibility of a positive and a negative slope. Rising means positive. Going down means negative. So up is positive, down is negative. And we always, always, always run right. And running right is always positive. So no matter what happens, you will be able to simplify slope so that the negative or positive is in the top, and there's always a positive in the bottom of our ratio of slope, rise to run. Okay? So, ladies and gentlemen, I got to clear this off. and we're going to bring out some more definitions of slope. There's a lot of definitions of slope to learn. The change in y over the change in x. Well, that is interesting. It's the vertical change to the horizontal change. So if you look at our graph again, we went up first. And we can go up first or down first. Well, the y-axis is what goes up or down. So the change in y, or the vertical change, is always on top, and the horizontal change running right is always on the bottom. That's the change in x. Now, the one last definition we're going to talk about slope today. There are many others. We're just going to talk about one more, just one of the others today. And that is y2 minus y1 over x2 minus x1. Well, y2 minus y1 represents the change in y. And x2 minus x1 represents the change in x. We call that the slope formula. So the slope formula is this equation right here, where we can say m equals y2 minus y1 over x2 minus x1. Don't let those sub-numbers fool you. Point A, I could call x1, y1. It's just the first point. It's just one of the points I'm talking about. And point B could be x2, y2. And let's call that my second point. Now again, I don't want to confuse you too much, but guess what? I could change the order of the points. I could call B x1, y1, and I could call A x2, y2. It does not matter. All that matters is that you're consistent about what you're putting into the formula, which point is your first point, which point is your second point, and then when you do the math and you simplify the slope, you will always get the right slope. You just will. So ladies and gentlemen, let's actually do it. We're going to calculate, oh wait, I got ahead of myself. Let's talk about the types of slope again. One, we have a positive slope. That positive slope means the line rises from left to right because we read from left to right. If we look at our ratio, we would either have a positive or a negative on top. My bad. Holy smokers. I'm just messing it up. Erase that. If we have this one, it's positive, we would have a positive number on top and a positive number on the bottom because this is a positive slope. It rises from left to right. If we have a negative slope, that means it's falling. The line is falling from left to right. We would have a ratio that would have a negative number on the top and a positive number on the bottom. Well, there's two other types of slope. Remember that horizontal and vertical line that we were talking about in the previous lesson? Well, we have a horizontal line here. And a horizontal line has a zero slope. If you think about it, our ratio, we would have a 0 on top. And why is that? Because starting somewhere on the left and going to the right, it does not go up or down at all. It goes up 0, down 0. So 0 is the rise, and then you have some positive number in the bottom of the run. And then we have our vertical line. Our vertical line is an undefined slope because if you have this ratio, well, going up could be positive or negative, makes no difference. But how far does it run to the right? It runs 0. And you know when you have a fraction, a ratio that looks like a fraction, that fraction bar is a division bar, and you have a 0 in the denominator. In other words, your divisor is 0. We divide by 0. It's undefined. So we call a vertical line 0 slope. So let's calculate slope real fast using a graph. And on the graph, we have this line with these points. And all you have to do when it's on a graph is you just have to count it. Ladies and gentlemen, all you have to do is count the rise to the run. So starting at some point on the left, I go up 1, 2, 3, 4, 5, 6, 7, 8. So my rise is 8. And then I have a run, and I count over 1, 2, 3, 4. I go over 4, and then I can simplify that to a rise of 2 over 1, which we learned a few moments ago, would be a slope of 2. That line has a slope of 2, meaning it goes up 2, and it runs 1. And I can do that. I can start there and go up 2 over 1. I'm on the line. Up 2 over 1, up 2 over 1, up 2 over 1. Like a stair step. And I keep ending up on the line. How about this one right here, where we have this line that actually falls from left to right. So now we're going to be counting down. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I go down 9. So my rise is negative because I went down. And my run goes to the right 1, 2, 3. This time I go to the right 3. It's always a positive. And of course this would simplify to 3 over 1, which my slope would be 3. Oops, negative 3. My bad, negative 3. So that means it goes down 3 and runs 1. Remember, if you don't see the run, it's equal to 1. Okay, if you don't see the run, it's equal to 1. So that kind of ends it for this one. We do have 3 videos tonight. So let's get on with our quick write, our first one, describing the slope of the line, and then find the slope. So I gave you a copy of these graphs. You just have to tell me by describing positive, negative, 0, or undefined, and then calculate that slope, ladies and gentlemen. And then take a quick break, come back for our second of 3 videos.